This 2021 paper 1 question 4, we have to prove the statement by induction. I'm going to assume that you understand why induction works. If not, I would highly recommend that you understand it because it makes it easier to remember. But I'm just going to go through the steps here, so if you don't understand it, probably won't really make sense. So first of all, we have to show that it's true when n is equal to 1. So our proposition when n is equal to 1, that'll be 2 to the power of 3 minus 1 plus 3 is divisible by 7. So I'll write divisible by 7. And what's this going to be? Well, that's going to be 2 to the power of 2, which is 4 plus 3. So 7 divisible by 7. Yes, that is true. Cool. So now what we do is we assume it's true for some number k. So that means we're going to assume that 2 to the power of 3k minus 1 plus 3 is divisible by 7. So in other words, I'm going to write it's equal to 7m for some number m. For some m in the... Well, there's no point in saying the integers. I may as well say the natural numbers. It could be an integer, but this is always positive, so it doesn't really matter. So yeah, this is how we can encapsulate it into an equation, which just makes life a little bit easier. And then our proposition for k plus 1, we want to use this fact to prove that it's true for k plus 1. So what are we aiming for? We're aiming for this to be true for k plus 1. So that'll be 2 to the power of 3 times k plus 1 minus 1 plus 3 is divisible by 7. So that's what we're aiming for. And just to make it a little more clear, that's 2 to the power of 3k, and then 3 times 1 is 3, minus 1 will be 2. So we'll have 3k plus 2. So let's see if we can make this look like this. So plus 3. If we can make this equation look like this equation, and then hopefully it should just work. So using our assumption, and I'll just write it down here for clarity. So here's our assumption. And what we can do is we can multiply both sides by 2 cubed. And you'll see why I'm doing that now in a second. So if I multiply the left-hand side by 2 cubed, so 2 cubed, 2 cubed, and then multiply this side by 2 cubed, well, then what we'll get is we add the powers here. So we'll get 2 to the power of 3k plus 2, because we'll add 3 to this. And then this is 8. 8 times 3 is 24, so we'll have plus 24 will be equal to 7 multiplied by 8 is 56. Multiplied by m. And now what we can do is we can bring it all to the other side. So what we'll end up getting is 2 to the power of 3k plus 2. I'm just going to bring the whole 24 over. Technically, we don't really need to do that, but I'm just going to do it for now. 56m plus 24. And now what I need to do is I don't want... Well, sorry, minus 24. Let me bring it to the other side. Bring it to the other side as a minus. And now what we really need is we need 2 to the power of 3k plus 2 plus 3. So I'm just going to add 3 onto both sides to get what we need. So 2 to the power of 3k plus 2, 3k plus 2 plus 3 will be equal to 56m minus 21 when we add 3 to that. And that's quite nice because that's the same as 7 times 8m minus 3. So since we can write 3 to the power of k plus 2 plus 3 as a multiple of 7, we can say that this thing is divisible by 7. So this thing is divisible by 7. The way to see that is if I bring the 7 to the other side as division, well then we have this thing divided by 7 is a whole number. So that's why it's divisible by 7. And that's exactly what we wanted to prove, right? We wanted to prove that this thing was divisible by 7. We started at our assumption. We ended at what we wanted. So that's basically all of induction done. So you need to write a little conclusion. So the conclusion you write is just summarizing what you did. So if it's true for n equals 1 and it's true for n equals k, then it's true for n equals k plus 1. Therefore, it's true for all n greater than or equal to 1. So again, I'd encourage you to make sure you understand why induction works, and then all of this stuff, you won't really have to memorize it. Then we're given an arithmetic sequence. We have to find the nth term. Okay, so basically our first term, a, well, that's just going to be p. And our common difference, you can see it's going up by 7 each time. So then you can use the formula in the tables book. So tn will be equal to a plus n minus 1 multiplied by d. It's on the sequences and series page. So tn will be equal to p plus n minus 1 multiplied by d, which is 7. So it'll be equal to p plus 7n minus 7. Doesn't really say how they want us to write it, so it's actually all right to leave it like that. Yeah, we'll just write it as p plus 7n minus 7. And yeah, that's our tn. Then we need to find the smallest value of p for which 2021 is a term in the sequence. So we want tn to be equal to 2021. We need to figure out when that can happen. So we'll have p plus 7n minus 7. Now we can do a little bit of analysis. So we need to figure out what n is. Well, I suppose n is the term of the sequence. Let's just simplify and we'll see what happens. So we said that 2028 will be equal to p plus 7n. And we see there's something going on with multiples of 7, so we might be able to understand it a bit if we get that by itself. So 7n would be equal to 2028 minus p. So basically what we get from this is that this thing has to be a multiple of 7, because if we divide both sides by 7, n has to be a whole number, so basically this side has to be divisible by 7. So what's the smallest value of p for which this is divisible by 7? Well, you can just check on your calculator. 2028 is not divisible by 7. Remember that p, is it going to have to be, yeah, p is a natural number. So you can check 2027, 2026, keep doing that, and you'll find that the smallest value of p for which you're going to get a multiple of 7 is 2023 is a multiple of 7. And if we went any lower than that, that would make p bigger, but we want the smallest value of p. So what we end up getting is that p is equal to 5 in order to make that true. And the reason for that is because 2028 minus 5 gives us 2023. If we make p bigger, we can get a different multiple of 7, but this is the smallest value for which it will work.